So, hello. Thanks a lot. I will have a quick setup here, but yeah, it's really nice that you're all here at this time. Last large session of the day. Probably later there will be the keynote, right? So I can only see that on one screen. That's a bit funny. So that's good, right? So hello. Glad you're all interested in MLOps and getting hands-on with MLflow. I'm Tobias Sterbak, as Simon said. I'm an NLP freelancer doing all kinds of stuff, machine learning, data science, mostly with text. Nowadays also it's more NLP, it's becoming more NLP and machine learning engineering also. And that's why also this talk came to be, kind of. I gave a similar tutorial in 2019, but some things changed since then on the MLflow stack, so I thought I'd do it again, and it was quite nice last time. And I hope it will give you some insights in MLflow, what is MLOps, what you can do, some overview. Maybe if you are familiar with MLflow, close some gaps, you see some new things, or see what other people might do with MLflow. So you can find me on a website called tobiassterbak.com. I have a blog with mostly NLP data science stuff, depends on the definition.com. You can tweet at Tobias Sterbak. And I have a GitHub where also the notebooks and the material for the talk is. The slides are not there yet and probably never will because they're not super great and will not be useful without me talking. Probably most of the content will be on the blog in the following weeks. So I have this blog here because later we will just do hands-on stuff. So before we begin, I have some questions for you quickly to check what's going on in the crowd. So who of you, raise hands please, trained a machine learning model before, something? So that's basically everyone, I guess, or kind of. And now next question, who of you tracked or used Excel sheets, Google Sheets or something to keep track of results of machine learning experiments or stuff? Okay, so few. So that would be interesting. Okay, so the following question. Who didn't keep track of machine learning experiment results at all? Or just dumped some files somewhere? Okay, so some people are honest. Cool. And then last question, who is familiar with some tracking solutions for machine learning experiments or used them before? Okay, so also a few people. So I'm wondering what is the leftover people, but we will figure out. So today I will try to answer basically all of these questions. And so MLflow might be a solution for stuff at a certain point in your machine learning maturity journey in the company or in the problem you're working on. Sometimes it's not the right tool, sometimes it's not yet the right tool, and sometimes it never will be the right tool. Let's have a look at the agenda for today. So first I will give you a brief introduction on MLOps, what are the goals, what are the ideas, really, really brief. Then I'll give you a short high-level overview over MLflow, what are the different components and what are they used for. And then basically we will only do hands-on stuff from there on, and I try to show you basic, not super basic setup of MLflow for tracking experiments, and having a tracking server and keeping track of what's going on. And then we go into how to manage artifacts like models from these experiments, these machine learning experiments, and how to deploy them with MLflow and keep track of the state of the resulting models. And then if we have time in the end, we probably skip this, but the material will be online. Tips and tricks, like what kind of stuff might be interesting for you at a certain point and might be useful to achieve certain outcomes. So what's MLOps and why should you even care? And so basically MLOps stands for Machine Learning Operationalization Management, or Machine Learning Operationalization, hard word. And it's basically, and nobody really agrees. It's I guess it's less agreed on what it means than DevOps, and that's even a hot topic, what that means. So it's basically a set of tools, right, to bring machine learning to production. That's basically what it's focusing on. It's focusing on taking machine learning models to production, maintaining them, monitoring them, and stay sane in the process, basically. And it tries to reduce the technical debt in doing that. So you want to be as lazy as possible to achieve and reduce the bust factor, basically, be fast and know where you left off last month, basically. It's important for me as a freelancer, right? Because if I'm coming back after a month, or if like I need to know what happened. And that's interesting requirement. And then lifecycle management. So you want to keep track of your release cycle. You want to know which models are used at what time, how they came to be, what data were used, what parameters were used, and you want to be able to reproduce that also for governance reasons, right? When someone says like something went wrong, you probably need to be able to track down what happened and where this model came from, basically. So that's the really high-level MLOps overview, and I mean there might be other ideas and other definitions. Yeah. So, and to see where this fits in the machine learning lifecycle, I give you a brief overview also there, what I understand on machine learning lifecycle. And I mean the material is by Databricks, or at least this picture. And yeah, and basically you start with data, right, on the left-hand side, and then normally followed by some exploratory data analysis. You look at the data, you try to figure out what is actually the machine learning problem you want to solve, you need to solve, what are metrics, what is going on in your data. Then there usually comes data preparation, data selection, feature engineering step. And of course, I mean, there are these arrows going in one direction, but usually they go all the way all over the place. But we call it life cycle because it's a nice cycle then, but usually it's not directed as a cyclic graph. And then we come to model training and fine-tuning, or tuning the model. There's a bunch of tools available for that. And then once you have a model, or you settled for a model and specific configurations, you probably do model review and need to consult people for model governance to check that the model behaves in certain ways. Beyond probably your machine learning metrics. And next step is you package your model for inference and serving. And then followed by deploying and hopefully monitoring. And then we have, at a certain point in time, probably a retraining step. In the ideal case, it's automated. I mean, here it's automated model retraining because Databricks has a platform for machine learning. I'm not affiliated with them in any way, by the way. So they, like Databricks, the company, built this open source tool MLflow that I like to use, but I'm not affiliated with them, and it's open source, so you can use it. Yeah, and as I said, usually you go back somewhere in the process and start from different points. And what we see today, basically, is we have model training. We try to collect information to have the model review and governance in place, and we can work there. And we see how to package the stuff and run inference on the models, and then how to deploy from a centralized infrastructure, basically. I would love to show also monitoring, but I have no idea how to do that in a structured way. It's so, from my perspective, so problem dependent, but it's super important, so don't forget this, and it's super important in your MLOps part. But yeah, maybe there will be a tutorial on this in the future. So that was MLOps, now MLflow. And as I probably said, MLflow is an open source platform to manage your machine learning lifecycle. So you can host it yourself, take the parts you need, and build some kind of machine learning platform around it. It has so far 4 components, 4 main components that we will look into. First component is tracking. It's basically an API and a storage format and a UI to record and query and keep track of experiments, of machine learning experiments, and collect all the relevant information to these experiments. Then there's projects. We won't look into that too much, but that's basically a packaging format to reproduce models with Docker or with Conda or something. So you can just package everything together, and someone else running it with this same data with a simple command gets the same model on a different machine optimally. I never found that too particularly useful, to be honest. So yeah, we won't look into that too much. And then there's models, which is basically a specific general format to describe the model you want to use and what needs to be done to deploy it. So it's a flexible format to manage deployments of models. And we also will use that. And then finally, and I find quite interesting and quite important here, it's the model registry, which is basically also UI and the format to manage the model lifecycle, to keep track of state of the model, to deploy from there, and to keep track of the model lineage, basically, like where did it come from, and what happened to the model downstream. Like when did it move to production? When was it archived? Was it on staging at some point? You can add features to that even. We probably will see that too. So that was basically the short introduction. So time-wise, that's fine. So at this point, any short questions? I mean, it was just high-level overview. OK, perfect. So everyone's happy or confused or both. So for the hands-on part, I will switch to Jupyter Notebooks. You can find the notebooks on this GitHub link. And there will be also some annoying installation instructions to get it running. I will now try to switch there. So this is somewhat readable in the back? I can zoom a bit probably if I can figure out how. So basically, so this is like, so what we need is we need a SQLite database, and I'm sorry, so like this is Linux. I wrote Linux, but it's of course only Debian based, I guess. So sorry for that. And for Windows, I have absolutely no idea what to do. And for Mac, it already should be installed, I was told. So we need SQLite. That's requirement to deploy models from the registry. And then I settled for pipenv here. So pipenv is the way to go. Other than that, I mean, if you want, there is also, it's basically 4 packages, right? So MLflow is installable with pip, so you can just create whatever environment you like and pick these 4 packages: Jupyter Pandas, scikit-learn, and MLflow. Cool. So then if you have Make installed, you could also just run Make Notebook, but we can just do run Notebook, and then it will open it probably in some very crowded browser that I don't want to use. And we go to the Chromium and look at this there. So I can also zoom. This is somewhat readable. I mean, it's a Jupyter Notebook, so the Jupyter Notebook, whatever, landing page. And then in the tutorial, so I might be a bit faster sometimes, but there will be breaks and exercises. So I start with the first part of the notebook, and then I have some small exercise and go around and check if everything works out so far. Sorry? Ah. Cool. Thanks for the comment. So yeah, so this is the first notebook, run track experiments. There we will see how to set up the MLflow Tracking server, the UI, how to interact with the UI, and how to actually run experiments and track them in the MLflow with the tracking server. So first, of course, I wanted some penguins in the presentation. So we were going to use the Palmer penguins dataset, which is basically a simple classification dataset as a drop-in replacement for the iris dataset, where you want to classify 3 types of penguins by their bill length, or how's it called, the Kalman measurements. So we have basically 2 features, 2 numerical features, and we want to classify into these 3 categories of penguins. Yeah, the dataset should also be included in the repository. If you clone the repository, you have the dataset. And let's see if all that stuff works. So we can load the dataset with pandas. So we see there's some measurements and some labels for those. Then we do simple, like the usual machine learning steps. We do a train test split with scikit-learn. We pick some classifier. I picked here decision tree classifier. You could later change it if you want. Yeah, with 2. I mean, it's a bit overkill to change any parameters here, but so we get, yeah, and then we evaluate and get some accuracy score for the classifier. So that's where we are, right? You started a machine learning project, you played around, you got the first metric. Now what to do if you want to iterate on that? And that's where basically MLflow tracking comes in. I probably ask at this point, is for who wants to run the notebooks, are they running now? So, and is someone trying to run them but needs a minute longer or something? Okay, so then we wait for a second. But otherwise it looks good, so that's good. I'm happy. Okay, so I just move on because now it's a bit more talking again. Sorry, I'm not sure if I understood, but I guess the question was like if we can see the Python modules again? I mean, I used 3.9. The question was if there's a requirement for a specific Python version. I used 3.9 here, but I guess everything over 3.7 should be fine. But it's not fine? I'm not sure. I can come back to you in a second. Yeah. It doesn't work with 3.8, so then they have 3.9. Okay, then sorry.
But it did work when you just log again.
Okay, so there should be a log file there. So if you install from the repository, it should then work. I guess I tested with 3.7 even, I'm not sure. Well. Okay. Minor setup issues. I'm sorry for that. I can try to come around in an exercise break and we can see if I can fix it or we can fix it. Now it's again a bit of a theoretical section here, which is basically the introduction to the tracking stores and the artifact stores. So MLflow tracking is basically composed out of 2 components, which is basically a tracking store, which tracks all the metrics, parameters, all kinds of stuff you want to track at some place. So there's a default path that can be a local file path, where it would just dump everything for one experiment in a file. Or you could use all kinds of relational databases, MySQL, SQL, SQLite, Postgres, basically everything that SQL Alchemy supports. You could use an HTTP server that listens to, or that has the MLflow Tracking server running. And of course, you can use a Databricks workspace, whatever that does. So that's the one side where you track the information of the experiment. And then there's the other part, which is the artifact store, where you store all the models, the artifacts, plots. I like to store all the source code there, for example, for every run. Like that's where you store all the hard, heavy stuff, basically. You could store the datasets if you like. And that could be also a local file path, or like something like the Amazon S3, Azure Blob Storage, Google Cloud Storage, and all kinds of other file system-like things where you can dump files. And so we go for like a medium heavy setup, which is basically, this does not even fit in the whole picture here. So but, I mean, if you have the notebooks, or you can look at GitHub, on the GitHub in the notebook, there you see this picture properly. So we use, for artifacts, we use a local file path, which we called MLruns. And for, as the tracking storage, what's it called here? Tracking storage, we use the SQLite database. The main reason for that is for deployment, for some reason, which I'm not sure what this is, MLflow requires you to use a database and not a local file path. But I guess it's because even with this setup, it's a bit annoying with the file paths because they're probably not absolute, and then sometimes things can get messed up. So we use a database to track the experiments. And that's kind of how it looks like. So we have an MLflow user code, the client API, and then two storage repositories, the MLruns for the artifacts, and a database to store all associated information to that experiment. And now you need a terminal, and you can run basically this command, which is basically uses the MLflow CLI tool to start a server at this SQLite database, or it will create it if it's not there yet. And the artifact root is basically the artifact storage that will be MLruns. And then it will run the server on localhost with port 5000. I would recommend running this in the tutorial directory and not in the root of the repository, just because then it works easier with the next notebook. And you probably need to run pip and run or check out your environment or something. So I will move to a terminal. And we do, okay, wait. Of course, I want to copy this. And pip and run. So I paste it in and try to zoom a bit. So like this. And now we see like there's Alembric running. That's creating the database and the migrations for the database. And probably it was already stupid because I didn't do what I said. So let's remove this again. So I mean, and if you mess up anything in this tutorial, you just delete these two files, like the MLflowDB and the MLruns directory, and then everything MLflow did to your environment and your stuff is gone. So then check out tutorial, and then run this again. So now we see we have the server running, and we can now open this localhost port 5000 in the browser, And then we should see the MLflow Tracking UI. It says, yeah, you can track some stuff now and run experiments. So the question now is, who arrived there so far? Okay, that's probably 50%. The what?
So with when we run the MLflow, either because of some local dependencies being different or something, the Gunicon server won't fit it.
Okay, I'm sorry about that. So who is in the process of still trying to start it and still has not given up? Ah. Okay, so one issue that occurred so far and possible solution. So issue was the required server wasn't starting up, and one solution could be change the port from 5,000 to something else. Did it work? So that was one solution that worked. Cool. So now you have the MLflow tracking server running. You can check in your file system that it created a database and the MLruns directory to store the artifacts. And now we can conveniently go back to the notebook, import MLflow, and the built-in MLflow scikit-learn tools. I forgot to mention that. So MLflow comes with a large bunch of built-in tools to track and keep track of existing machine learning libraries, like for example scikit-learn, and they call it flavors, and that provides like a super easy access to all kinds of stuff related to these libraries and to tracking and deployment. And they even have functionality for example, for scikit-learn for auto-logging, where you really don't have to do anything other than call autolog, and then it logs whatever it thinks is appropriate to log for a scikit-learn model. We don't do it here for different reasons, because we are more flexible if you know how it works under the hood. And I never used autologging, so I feel a bit weird to tell you about it. Good. So we use the scikit-learn flavor here to make our lives a bit easier. Then we set the remote server, like we point basically our tracking server, we put our tracking server address here and let MLflow know where we want to track. This is especially important, right, if you have a distributed server, or a server somewhere in the cloud where you want to log your experiments, for example, as a team or so. Right, so here we set it to the localhost port 5000, and then we can verify, yeah, it's actually set. Yay. The next step is we create an experiment. We give it a name, and then we call MLflow create experiment. This is like the explicit step. You could also just check out the experiment, but I like to keep that explicit here. You can also create an experiment in the UI. You see here some experiments. Right now it's only the default experiment. You could add an experiment here. But that's probably something you don't want to do.
Is MLflow compatible with Windows 30?
So the question was if MLflow is compatible with some Windows. So sadly, I have no idea. I haven't found any Windows users to test it also. So I don't know. But in theory, it should work if Python works. But maybe someone in the audience knows. Yeah, with Windows, I'm sadly not helpful. Sorry about that. Okay, moving on. So now we've seen in the beginning the basic machine learning stuff we want to track. We want to run, and now we are presented with the opportunity to track that stuff. And there are two basic things that MLflow wants you to track, or you probably want to track, and one is parameters, which is all kind of configuration stuff for your model, like you would the depth of your trees or the number of data points or something like this, which you can use MLflow log param or log params if you want to store. So yeah, the log param takes key value pairs and the log params takes a dictionary and logs them multiple at the same time. And for metrics, which is basically things you want to compare and check, compare your models on, you can use log metrics and log metric. We will see later how that is different in the UI. So as you remember, this is the code we had before, right? And then now we add to this machine learning code, we add the MLflow tracking code. First, here we have to set the experiment, like tell MLflow where it should track the stuff in the UI. So we see you have here, you probably have to refresh, right? So we see we have here a second experiment that's called penguin classification, which is currently empty, has the ID number 1. Okay, so we set the experiment here for the run, and then we start the run with this context manager. So it says MLflows.run, and then you can pick as run. This is not directly required, but I like it so you can have some output on the run. Like, for example, you get the run ID, which is the central information, like the central piece of information you need to know which kind of experiment you're talking about, like your git hash for a commit or something. So then we just load the dataset as usual, do the train test split, and then here we start logging the parameters for decision tree classifier. So we basically call MLflow log params with the dictionary with the name of the parameter and its value. Then we instantiate the classifier and train it. And at the end, we log our test accuracy with MLflow log metric. So if I run this now, you see the output here now because I didn't clean it. But then you see, okay, this is the custom output I put there. And if we go and refresh the UI, we see, okay, there's now one run recorded. It's coming from a Jupyter IPython kernel. I created it, and this is the output. And we see here it differentiates between metrics and parameters. And if we click here, we can also go and see the specific information of this run, the run ID, duration, and certain information, lifecycle stage. You can add a description here, and here we see the parameters, metrics, tags and artifacts. So currently we have no artifacts recorded. That will change soon. And we have here test accuracy that we can compare, that we also do later once we have more stuff to compare. Good. So, and now we come to the first exercise. Track some more stuff, right? So right now we did the basic of the basics, but you could track, of course, more stuff like Git versions, or like code versions, start and end time. Sometimes it's also part of MLflow already. I like to track the source code, like if I have a script producing the model, I like to the library to create the model, I like to log all the source code also. You can just copy it to S3, and it usually doesn't matter if you dump a few more kilobytes on S3. If you know in the end, this is the exact code. Git commit hash is also nice, but usually I'm not committing every different machine learning experiment I run, because if I only change some parameters or something, or some small stuff, then I'm not sure if it works, and otherwise my commit history is completely crowded with stupid minor changes to model parameters that I probably don't want to have in my code, right? depends. So properties of the input data is probably something you want to track, plots and model artifacts, like the output of a model. So what you could track now, for example, is like examples here, is one of the properties of the input data, like the shape or the number of samples or how the split is done or something. Or you could track the whole notebook source code, right? But for this, MLflow has a specific function which is called log artifact, which takes a file path, a local path basically, and puts it to the artifact storage. It could load it up to Google Blob Storage or S3 or whatever file path you specify. So yeah, so here in this exercise cell, you find the code from above that you can modify now and probably track some more runs, right? And how long do we have? Probably 5 to 10 minutes. And I walk around and answer some questions. And then we can move on. So, cool. So, some problems were solved. Everyone basically resolved them themselves. So, cool. So let's move on. You had some fun with tracking some different stuff. One thing that was pointed out to me, and one question I had, someone had, was if you can track, for example, environment variables, because there are different ways, right, how you would pass information to your script. And yeah, sure, you can. I mean, you can track everything to the parameter store that you can access as a Python string or Python whatever. And you can track everything and log everything to the artifact store that you can access in a local file system. So here's this possible solution, and we see how to log, for example, a local file, in this case, the notebook itself. So first quick, like here's the number of samples logged as a parameter. Could also be logged as a metric, depends on how you want to use it. I keep it as a parameter here. And then the second thing I suggested was you could log the notebook. So here we just point to the notebook. I mean, this is a path. It's in the same directory, so it's not super exciting, but you could also log the whole code directory, for example. And if we run that, we see, okay, same output. But in the repository, I need to get back here. I'll get rid of this. We see there is no artifacts. No artifacts here.
Is the latest one?
I'm not. Thanks. Yeah, good point. So here, yeah, in the artifacts, there's now the notebook itself, and you could put it in a deeper directory if you want. So there's different options where you can put that. So, and now the important part, basically, or one of the important parts, is like how to log the model. So we of course want to use the model artifact later probably, and we want to go back to it, and we want to deploy it, and we want to keep track what it is actually. And since we use the scikit-learn model here, things are quite nice, but it's also there for PyTorch, for TensorFlow, for Keras, for XGBoost, for whatever. There's inbuilt flavors, as I said. And here we use the MLflow scikit-learn log model, and you just pass the model. Here's it's called tree, and give it a name so that that's basically the directory where it's put on the MLflow artifact store. And then we can put this at the end of our script. So here's the log mlflow.scikit-learn.logModel. And then if we run that, looks the same. And we see, so first thing we see is we see a model with the name of the flavor in this case, but could be also custom thing. And we see here, this is in the artifact, now the models directory appeared that contains different things to reproduce the model and specifies how the model, what the model is. Like in the models, ML models file, for example, you see description of dependencies and different information. Conda environment, requirements, pip environment, specification, and then there's the model pickle to basically get the model back. So now I have another small exercise, but I guess most of you already did it. But run this code with different parameters. So I will quickly do that, and you can also if you want, but we won't do it longer than I need to. It takes me to do it. So we create different outputs here. Let's say this. Some of them are stupid. So this is probably not good. This is good. So we create a few things that we can compare something. So, okay. So and if we go now to the UI, I was confused. So there's now a few more runs. We see here also failed runs. Now because I failed to run them properly. And now we can select, for example, here we want to compare them, right? So we can select these 4 runs because they were successful, they have a model. And then, I mean, if you're only interested in test accuracy, nice. You can look here and say like, well, this is the best one. I'm happy. But you could also compare them and see like how get different plots to inspect the model based on parameters. Like here's the partial coordinates plot. You can get a scatter plot, where depth versus accuracy, for example. Probably other way around, depends, yeah. Or you can see the run specifically and how the parameters affect performance and the metrics. So, and here you could jump directly to the specific runs and see the details of the run. So, yeah, feel free to play with that. Good. Compare models in the UI, done. Yeah, sorry.
I have a question. I tried to store data.describe, the result of data.describe, which is a data frame, and failed. And then it's is there a possibility to do this?
So the question was, can we store the result of data frame describe, like pandas data frame describe? And yes, you can. You cannot store it. So the log params, log metrics, take only key value pairs of simple. I mean, simple types probably hard, but like simple types, like numbers or strings, but not data frames. So what you can do is you can write it to file, and then store the file, which is usually what I would do. Like if you do like create classification report with scikit-learn or something, would write that to file and store it, and then it would appear here in the artifacts as a file that you can read like this, right? And you can look here and see like, well, but it's hard to compare then. So if you want specific information, I would recommend logging it as a parameter or a metric. But if you say like, okay, I have a model, I have a long classification report, different details, I want to load plots, specific plots, then I would log them as files. Cool. So, I mean, optional, but I guess we will do it. How long do I have actually? How long is it still?
You have 25 minutes.
Okay, 25 minutes is cool. Good, 25 minutes will be fine. Then we do that. So, signature, which is basically an API, how's it called? I forgot. API schema that you can attach to your model. That is important and interesting later in deployment. So if we look, for example, at the current model here, it says like, well, here's no model schema. Sad. So what we can do, and I mean, I just give you here the code. So you could also do that if you want. So we import the relevant stuff, model signature and the schema, and then we can specify every input column as a schema. We expect double here and to give it a name. We specify output schema, we output strings, and then we create a model signature from that. And that can be passed here to the log model as signature. And actually, if you deploy that later, MLflow will enforce this schema. Otherwise, it will fail internally if you pass something else, right? But if you have a schema in place, then it will be enforced. Note that different deployment or deployment tools like SageMaker or Google Cloud or something, they might not enforce it in a way like you expect, or sometimes don't enforce it properly, given the runtime. Yeah. So run this, and now if we refresh here, we see another model, and now this has a schema here that says, okay, this is what I expect. This is the output I expect. We didn't give the output a name. That's probably bad. We should give it a name. Good. And now what we finally can do is like to simply test the model and references from the experiment log. Even is like we can deploy, like run it locally, like we retrieve it from the artifact store and the tracking server. So actually, I mean, it will talk to the tracking server. The tracking server knows where the artifacts are stored, brings everything together, and loads it locally, which can also be a first step of deployment, depending on how you like to work with it. But here, this is how you would reference different runs in MLflow. So this is runs column, and then this is the run ID, and this is the name of the model, or basically the directory in the artifact store of that specific run. So, for example, here it would be this ID, right? I need to get some ID now because the ID in the notebook is obviously old. So I need this one, and then I know it's called model here. So I go here, say, okay, this is what I want. And then it loads the model, and then we run the same test data basically again, and we see, okay, we get some output. Cool. So that's part one. Now tracking is up and running. MLflow is properly starting to fill up with stuff. And now we want to move to the second notebook and see how to deploy and keep track a bit of the state. So as we saw before, and there was talking about is MLflow Models, is basically a specification of how the model can be packaged and reproduced and run. And the built-in deployment and serving tools of MLflow basically reference this format and put together environments so you can run your model basically everywhere. Hard to say, but yeah. So you can, for example, push it to SageMaker, push it to an Apache Spark cluster, push it to Kubernetes with a Docker container, do different stuff, push it to Azure ML. And MLflow makes it quite easy. We will not do most of the things now because probably there's no SageMaker or Kubernetes available. At least, yeah, not for this tutorial. So basically the format is this kind of YAML format in the models repository, the models directory that specifies the flavors. So it's a scikit-learn. We can deploy it as a scikit-learn flavor, and the lowest possible flavor is the Python functions flavor, which could basically run everything that is a Python function. So I probably put this in here now. So you can write your custom models there, and I like to do that. You can put all your pre-processing in there and track this also with MLflow. And then you would deploy it as a Python function, of course. And you can deploy any kind of Python function with this functionality. Yeah. So, and the simplest way to deploy as a HTTP local REST server is basically with MLflow Models serve and then point to the model. I'll show you in a second the proper command. So we talked about MLflow Models, and now we talk about the model registry, which is probably, you noticed, another part of the UI. And now there's a bit of confusion. So the model registry is basically a component as a centralized model store. Like you have a set of APIs, a UI, and some conventions to manage the lifecycle of an MLflow model. That becomes mostly interesting once you have at least a small team, but also for a single person project, it might be interesting to know what happened in the past to your stuff. It provides model lineage and tells you like which experiment and which run led to some model and what happened to that model, right? Model versioning, stage transition, for example, from to staging, to production, to some archive, or to delete it even. And you have another set of annotations available. There's a bit of confusion here because there's like the model, which is the model as an MLflow model. And then there's a registered model, which is a model that is registered in the model registry, but will be also called model. Okay, but we will see the difference, I guess. So, and there are different how to register this. Wait, I should do probably this for, better. Blah, blah, blah. So we start again by setting up and pointing to the tracking server. And now we want to register a model in the code. So we say, okay, how do we want to call our model? That's a penguin classifier CLF. And for this, we use a little bit lower API of MLflow, which is the MLflow client API. And there we create a registered model with that model name. And I mean, I put it here in a try except because if it already exists, it will complain. But so, and then basically we know, okay, we created a registered model, has no description so far, no versions, and there's a name and no tags. And in the UI, you can now go from experiments to models. And there you see now there's here Penguin CLF created. You could also create it here in the UI by clicking on Create Model. And we see this has nothing inside of it, so no versions, nothing in staging, nothing in production. So we want to change that. So registering a model is actually quite simple. And again, there are two ways. There's always or probably even three ways. There's also the CLI way. I'm showing you here the Python API, and then of course there's the UI way. You pick a run ID that you want to register. So we go to the experiments. And what do we pick? We want this one probably. So I have this run ID. Copy this over here. And then we call MLflow register model, point to the specific model file in the artifact store, basically, like runs, and the name where we want to register it, which is basically the name of the model we created, we registered. And we run this. Okay, so it tries to say, okay, probably it didn't exist, so we check. Okay, it says, all right, it already exists, so I create a new version. And it created version 1 of the penguins classifier. And we can see again the results. So this is basically the model that is the model version is created at no stage, has a name. It's linked to this run ID. This is the path to the artifact store, like to the model in the artifact store. It's ready, had no tags, no status messages so far, and version 1. So if we go here, we can see it here. So there's now one version, and this is it. One thing to notice is now in the experiment UI, you also see that this model is now part of a registered model of version 1. So it's not scikit-learn anymore, so it's now a registered model with a version. that's that. And you can go back here to the run and see the run and the results, the parameters and metrics and stuff. Good. So next. Yeah.
Question.
Yeah.
So on this print statement and creation timestamp, how could you decipher this? That is just a hash? Or
No, that's a Unix time. Seconds since 1970 something. Yeah. Sorry. Yeah. The question to this answer was what these timestamps mean and if they can be decoded, like what they are, and they are Unix timestamps, and they should be here in the UI. They should be proper timestamps, like they should be decoded in the UI. So registered here, last modified here. It's just for internal handling. Any other questions? Please.
So the registered model directly references the pickled model.
Yes, and the run. So the question was if the registered model already directly references the artifact stored model, the pickle file basically. And yes, I mean that's the case. It basically points to the location in the artifact store and to the specific run. Yeah.
This means if we delete the runs, then the register is broken?
Yes. So the question was if we delete the runs, then the registry is broken. Yeah, it should not let you delete runs that are connected to a registered model. And I mean, if you delete your database, if you lose your database, if you delete your S3 bucket or whatever file system, of course, stuff is lost. Yeah. But play around with it. That's the time for breaking things. Yeah, please.
Can you include some kind of lifecycle policy for the runs in order to get rid of all the unused models?
I mean, so the question was if we can enforce or use some lifecycle policy to get rid of unused models or unused runs. And so short question is yes. So there is nothing in place in MLflow to directly say, like, I want a lifecycle policy. But like register model or create experiment or something, there's a bunch of functions available. I'm just not including them here in the documentation. There's a bunch of like delete run, list all runs. You can iterate through runs and check if they link to something, and then you could delete them automatically. So you would have to write your own script or your MLflow node or whatever you like to enforce it yourself. I mean, MLflow basically gives you like a UI and some conventions to put things together, and then you can, I would say, quite easily and with a reasonable effort add functionality as you need it to make you happy. Yeah. So good, we have this registered. And so now we want to serve the model from the registry. And the steps are basically similar for different deployment tools. Some deployment providers like SageMaker or something, like AWS SageMaker or Azure ML, have also Python API available. And I guess Kubeflow is also something that's part of MLflow. But yeah, we won't do that here. But it is possible and it's relatively convenient. So what you need to do to run this from the CLI is basically this command. As I said, we do MLflow model serve. You tell it where the tracking server lives as an environment variable here. And since I didn't list conda in the installation requirements, we use no conda. Otherwise, it would create a specific conda environment. Here, it will use pip. You could also use Docker here, but also I didn't want anyone to install, like everyone to install Docker here. And then you point to the model and the version of the model you want. And you tell it the port where it should serve the model. You can also, if you later we will see transitioning to stages, you could also tell it the stage here. You can tell it the version or you can tell it the stage to deploy. So now we can do that, right? I mean, probably you need to put pipenv run before that, between MLflow and 5000. So new thing. So pipenv run. We point to the tracking server again, and then we run this. So let's see. And now we say, okay, it gives us a bit of information. So it says like, well, we deployed with backend Python function flavor, and then it basically started a scoring server that's listening on port 4242 conveniently. And now we can use, for example, CURL to invoke the endpoint, and the endpoint is always on /invocations. Or we can use the requests Python library to query the endpoint. One important thing to notice here, if you want to send JSON or something, structured data there, it's most of the time recommended and necessary to tell the MLflow endpoint how to decode your data. So here we have, so you pass a format with the content type and tell it it's a pandas records, which means it should use the pandas load from records, or pandas from records, or data frame from records, and yeah, something like this to load this data into pandas. And if we run this, okay, we see, okay, it worked, 200, and we get some predictions. And I mean, these are also completely made up values, but you get some predictions.
Can I jump here
Yeah.
really quick? Because we have 3 questions from the online community.
Okay, please.
And number 1 is it possible to log the entire pipeline of the model? For example, the pre-processing steps?
So if you have a scikit-learn pipeline, so yeah, the question is there. So if you have a scikit-learn pipeline, then it's quite conveniently the way we did it here. If you have different pre-processing steps in place, you would probably write a custom model, which is basically a Python class that at some point has a prediction function, and that can be used there as a Python function. I can in a second point to the part in the documentation, and I prepared a bit for it. So yeah, I would recommend it in general. So I never used it actually with the built-in flavors. So I always have like a custom thing, which is not too hard, and then you can really track everything you did. And you can expose also everything you did and not just have a model and another thing around it to have a production-ready API kind of. That's it. Yeah. Do you have more questions, right?
Yes, I have 2 more, but I think this one lost a little bit of context. It asks, you have to set the environment variable separately, right? It's not part of the command. Unfortunately, it doesn't mention which command.
That might refer to this, right? Yeah, I mean, there's one environment variable you have to set, the MLFlow Tracking URI. That should be enough to run everything here, but yeah, I'm not sure. Ask again if you want more.
And then question number 3, also how to ensure that the model dependencies of the pipeline are the same once we serve the model.
I mean, I was in the DevOps talk before, and it seems not too easy, right? But here, MLflow tries to do that by giving you pinning the versions in the model file. So if you go to the model, see here there's a conda YAML which basically takes all the requirements from that are needed to run the model and tries to pin them as possible. Yeah. So that should hopefully recreate it if possible. So it's you have to be a bit more careful. Again, if you have a custom model, you need to probably log your code with it to have it available in the environment, right? You cannot just rely on the pickle file if you have custom code locked, but yeah.
Okay, thank you very much. I think these are all questions so far.
Cool. You had a question?
Yeah, can I serve my model with a custom API?
You can also do that. There's also in the documentation a large part of like a large section on how to write your custom deployment targets and how to set it up. I have not done that yet, I have to say, but should be possible. Good. So let's. So there's a lot of stuff where you can deploy that, and probably the final thing we want to do here is transition the stages. So if you have a deployment script, for example, you at some point, so MLflow does not directly deploy stuff. You have to tell it to deploy stuff. And then you have a deployment script, and in the script, you probably want to transition the stage, right? Here we would jump to just production, but you could also jump to staging. It has 3 environments, 3 stages available: staging, production, and archived. And then there's also the deleted stage, which only shows up in runs, I guess. So, and this is also, again, with the client API. So transition model version stage, so we reference the model name, which is the registered model name, the version, and which stage we want. And there's also, again, the client has a bunch of functions or methods to manage these stages. I'm only showing you one to see it. And then this is the output. And now the model, which is basically a reference to the model in the registry. And now we see here it's in production. And if we go to the UI, we see, okay, version 1 is in production now. Here it means nothing, right? But it's in production, and here probably, does it change here? Now it still stays version 1, right? But if you go here to the run, no. Good. So that's part 2. I guess we have done at 4, right?
No, you have 15 more minutes. We have until quarter past.
Cool. Very good. Then we can have a quick look at some tips and tricks. It's not too many, so we can have a look. What I also find interesting.
Sorry.
Yeah. Or more questions.
Before you move on, can you deploy? Is it always just deploy to the port? Is that the only target for model serve, or can you specify a path?
Can you say the first part again? I just didn't understand it acoustically, I guess.
The model that you're making a request to, always one-to-one map to a particular port that you're deploying to, or can you have different paths for, say, here's the staging/production, have the model name in there? Because in your invocation in the example, I only see you're hitting the invocations endpoint, right?
So if you can the question was if you can basically have multiple models at one deployment endpoint, I guess, like here. So you cannot, as far as I know. So it in the end it all MLflow, at least the built-in deployment tools, all rely on you point to the MLflow to the endpoint invocations. You could have a custom model that takes multiple data points and probably has different model artifacts inside of it, but that's a bit of a hack, I guess. So you would probably deploy multiple models.
I have another 3 questions from the online people.
Cool. Bring them on.
As a follow-up to one of the previous questions, is it possible to install the dependencies in runtime? For example, if we use the model in an API.
I'm not sure what to answer there. So if you run them with, for example, we picked here no conda, for example, because installing conda might be a bit annoying, and I didn't want the additional dependency for the tutorial. But if you want it with without this no conda, for example, it would create a new conda environment, for example, for every run, for every time you call this command and deploy it in this environment, for example. You can do the same with the Docker. Then it creates a new Docker image for every time you call this and then starts this. Or you can, for example, for other tools, like if you want to put it to ECS, for example, you do build and push, and then it creates a Docker container, pushes it to ECS, and you can run it from there, for example. And then, of course, it also installs the dependencies every time, fresh. Hope that's answered the question.
We will know in about 5 minutes when the next message is in. What's the default strategy to do when you're serving a model in an API and you train the model again and wish to switch the model being served to the new one?
I mean, that's quite a general question, I guess. Can you say it again?
I'm afraid I can't. I already closed the issue,
okay,
sorry.
So, I mean, optimally, it's hard to answer. I mean, I would say you switch, for example, your Docker container completely. You have your model return some versioning, for example, could be the model run URI, the run ID, for example. Then you can identify later in your where you store the predictions of your model, for example, you can identify where it came from, and you just switch out Docker containers, for example, behind your API, and then you have a little downtime probably, or you have like some rolling deployment. Depends on what tools you use. Yeah, hard to answer. Maybe someone else knows.
Follow-up question to that one. Can you have 2 models in production and try to run the traffic maybe 90-10%?
So the question was if you can have more, like let's say 2 models in production and split the traffic between them. So MLflow is not in place for managing this kind of deployments, I guess. You can have different versions in place and different models in production, but then you have to do 2 deployments, right? So you cannot deploy these 2 and split the traffic. So MLflow is also not routing the traffic. You have to say, okay, I have this endpoint, and it's a singleton endpoint. And you can have 2 endpoints, but then you would need some solution to manage how the traffic is distributed. I mean, SageMaker, for example, would do that for you, or Azure ML, as far as I know, would do that for you. You can say, like, okay, I have 2 models, I give them different weight. But MLflow internally cannot do that and doesn't manage that, as far as I know.
And then there's this last question from Discord. Is there a way of decoupling the MLflow code from the actual model code?
So I guess that refers to this part here. I'm not sure what it refers to. To me, the model code and the MLflow code is reasonably decoupled. So, I mean, sure. I mean, okay. I mean, probably it refers to this mix-in of, like, you have MLflow calls and model and scikit-learn and other stuff calls in between, and you probably don't want that. So, I mean, sure. What you could do, and I've seen that, is you, for example, build that as a decorator, or you just start a run here, collect all your stuff that you want to track in between in some dictionary or something, and in the end, log it to MLflow. Or you could create a decorator, and I've seen that, that you put around your training function, and all outputs are basically logged to MLflow. I'm not sure what I prefer. So you can do that. You can track it at any point. I mean, you just need to. I mean, this is also only one way to tell MLflow where to run and where to store stuff. I mean, you could also directly call up an old run, for example, with the client API and say, like, well, I add some more information there. I have some new information. That would be parts, for example, of the tips and tricks. For example, you could have like a model integration test at some point, where you say like, well, I just started like here, I run something at the end, I loaded it, I probably have some other Python code around, I run that. And if that passes some specific requirements with some test data, I add some information to the repository, like to the model itself. Like here you could, for example, add a tag, right? Tag. And then if you want, for example, to move it to a stage or to move it to a model version, this tag needs to be there. You could check that. So, I mean, briefly here, you can, for example, list the experiments, and then you can set a tag to a specific run ID after the model was run. This is in the tips and tricks notebook, for example. And I forgot to repeat the question, I guess. Sorry. Yeah. I only understood half the question, sadly. So I guess the question, so I'm still not 100% sure. I guess the question was if we can log the scikit-learn parameters from the context somehow, right? Yeah. Yeah, for a lot of for a lot of built-in flavors, there is actually called a function autolog. Like if you go to MLflow documentation, we can whatever. There is there's all kinds of built-in functionality. So there's the automatic logging for all kinds of libraries. And there we would basically only call MLflow, where is it? Oh yeah, you would basically just instantiate autolog and then it would discover everything, right? I mean, it might be beneficial. I don't like it too much because I need flexibility, and that would be also my answer to, would you decouple the machine learning code and the tracking code more? And again, you can do it, and I've seen it, but I don't like it too much because I want to know where the thing came from that I'm tracking and not hide it further. But sure, if it gets super complicated, then you can think about doing something. Yeah.
Is there a user or permission?
No, I mean so the question was if there's user and permission management, and the short answer is no. I mean, you can see here which user did something, so that is logged, but it's only your file system, like your local running user. So there's no permission management and stuff. Yeah. You for right first, like left. Oh. No, it uses so the question was if it uses an SQLite database on the server here.
Yeah, now we use a few examples, but like you have a production somewhere, do you like really on some cloud data lake or some server for the company or something, do you like really have one supply somewhere, like with hundreds or?
I mean, so SQLite is so I'm not sure for the reason, but MLflow requires to have this deployment and registry stuff working requires a database backend, I guess because of the file paths. And the question here was, like, if I would really use an SQLite database in a production setting on some server somewhere, right? But of course, so you can do that. I mean, usually that only stores the parameters, right? So it's not super critical data, and doesn't have to be performant in general. So if you just have a backup for that thing in place, yeah, that's something I would do. But you could also point it to a Redshift if you want to spend money. Or you can run your own Postgres or all kinds of different stuff. So if you look here, there's a lot of different scenarios also available or like described here how you can store artifacts in runs, right? And I mean, I grabbed stuff from here, but there's all kinds of different setups that you can do, like with a proxy, with different remote hosts. So, yeah, there. The model is always saved in the artifact host or the artifact store. So, I mean, in our case, it's now in the local file system, right? But you could also point it to, for example, an S3 bucket, for example. Let's see if I find it quickly. Okay, I don't find it quickly, but it's probably also in this notebook, quite at the beginning. So I mean, you could. I mean, I would just dump it to. I mean, you just dump it to some S3 bucket, and then you have the run ID, and then whatever artifacts you have there, like or basically experiment ID, run ID, and then all artifacts to this run. Basically, like you would have here in the ML runs, right? Then you have experiment ID number 1. Then you have different runs, and you see, okay, here's artifacts in there. And that's then how it's stored. Yeah.
Maybe one.
Okay, we continue with this question quickly.
Yeah, maybe a little bit more of a general question. There are lots of cloud providers are now also providing a lot of MLOps tooling, GCP with Vertex AI, Azure with Azure ML. When would you use like an MLflow-based solution instead of like one of these cloud-based solutions?
I mean, so I guess one benefit of MLflow is you can start quite. The question was, there's a lot of built-in cloud provider solutions for this MLOps or management of models and stuff and training. Why and when would you use the MLflow then? So the largest benefit to me from MLflow is you can start small, really small, like single developer on local machine and have a benefit, and then from there move on to some platform, and you can customize a lot. And then some cloud providers only give you parts of the equation, right? And you can use, for example, MLflow to patch it together. So that's, for example, something I do, or what I commonly did so far is like have, for example, SageMaker handling all the really deployment stuff. I don't care. I don't want to handle security stuff, blah, blah, endpoints. Someone else can take care of that. Infrastructure, but MLflow for tracking experiments, and then it's isolated in SageMaker, for example. So you can piece together things if you want. But sure, I mean, if you have a cloud provider and you know, hey, I have like a 50 or whatever, a data science team, and I know I want to do X, Y, Z, then you can probably just start using a cloud provider. I mean, there's different solutions for that. I mean, I guess also DVC is quite nice, right? I haven't worked much with it, should offer parts of this functionality, so MLflow is far from the only tool for that. It's just some tool that was around when I started looking for such a tool, and then I started using it. And now I'm a bit stuck with that because it's convenient when you know a bit what you're doing. But yeah, there are different tools and other stuff. I mean, you could also use weights and biases or something for these kind of things, right?
Cool, thanks.
You're welcome.
So I'm afraid we have to come to an end. Maybe we end on a very brief question from our online community, which is about the integration with continuous integration and deployment tools. How well does it integrate?
I mean, that's quite a general question, right? I mean, depends on what you do and how well and how much effort you want to put in managing your environment. I mean, if you can get your whatever Bitbucket, GitHub, GitLab runner, for example, to interact with a remote server outside of GitHub, and you get your company's IT department or security department to allow that, then they integrate probably quite nicely. Yeah, depends on, I mean, in the AWS environment, you probably can do stuff with code build and without leaving the ecosystem, which will probably make some people happy, specifically AWS. Yeah, but yeah, I don't know too much about that, to be honest.
Okay, then thank you very much for an enlightening tutorial.
Yeah, thank you.